back to our channel. So in today's session we'll discuss about the implementation of queues using linked list. So queues using linked list in Python. So already in our previous session we have discussed about the linked list, circular, double and stacks. Now we will go with the queues. So we know that queue is a FIFO structure, that means a first in first out. So whatever the element that enters into the queue first, that will comes out. So here there will be two ends, one is rear end, another one is a front end. So rear and front. So at the rear means back side, right? Back end. So the insertion will be done at rear. The insertion will be done at rear and the deletion will be done from front, right? So that will be represented in this way. So if one element is entered, so this is the front and this is the rear, right? So immediately see, whenever the second element enters, second element will be inserted here and it will be the rear. And whenever the third element enters, the third element will be here and the rear will be here. And if you delete the element, the 10 will be deleted. So the 10 will be deleted and the front will be moved towards the next one. So in such a way, the queue will be executed, right? So two ends will be there, rear and front. Though all the insertion of elements will be done through rear and deletions will be done through front. Now we will see the implementation in Python. So first, initially we need to take the linked list. In linked list we will take a node, so which will be having the data and next. So the data will be the normal data, whatever the element we are inserting, that element will be initialized to data, and initially the next will be none. So whenever a node is inserted, immediately, so that will give here, so the element and none. Right? So this is the data part and this is the next part. Right? Now we need to initialize front and rear. Right? So initialize the front to none. So I'll write here. So initialize the front to none and rear to none. So I'll explain you the concept and then we'll go with the interpreter. I'll execute the program. Okay. So no, you need not worry for that. So first let us see the insertion. Let us first, we will see the insertion of an element. So we have seen that the insertion will be done at the rear end. So here case 1. So before insertion, if queue is empty. So how can we know that queue is empty? So if front is none or rear is none, any one of these is true, that implies so queue is empty. Okay, if there are no elements, so both front and rear will be initialized to none. So if both are none, either one is none, that implies the queue is empty. So if it is empty, we need to create a node, insert a node. Okay. So initialize. So a data to a data and next to none, and simply not a data. So friend is equal to new. So how we will create some new is equal to some node of 10. Node of 10. Immediately the 10 will be displayed here and none will be initialized here. So after executing this statement, new is equal to node of 10, a node will be created, and if Q is empty, this will be the first node. So if it is a first node, we have to initialize the new to front and rear. So simply rear is equal to new, and you need not go with the next. By default it will be none, right? By default it will be none. And case 2, if Q is not empty. If Q is not empty, that means at least a Q consists of at least one element. What we have to do? So again, go with this one. New is equal to node of 10. So here let it be the Q is having 10 and none, and one more element, one more node has been created. So after executing this second statement, that is a 20 and none, right? 20 and none. So the value is 1000 and the address is 2000, and here the front and rear both are pointing towards the first node, right? So both are pointing towards the first node. So now after executing this statement, new is equal to, sorry, this is 20. So that should be inserted at the rear end, right? Insertion will be done at rear end. So here it should be. So you need to establish the connection between these two nodes. You have to establish the connection between these two nodes. So what we have to do? So simply rear. So this is a rear. So you can write here rear dot next. Don't write front dot next, because here it is a single element. So obviously rear dot next or front dot next both are equal. But if you are having two elements, then front dot next means this element will be modified, right? So I'll explain. Let me explain this one. So rear dot next is equal to new. So obviously this none will be replaced with 2000. So if 2000 is here, there is a link established between these two nodes. Now what we have to do? Rear is equal to new. So here the rear will be pointing in this place. That's it. So simply rear dot next equal to new and rear is equal to new. For example, if you are trying to insert one more element, so node of 30. So let us take, so this is a 10, this is a 2000, this is a 20, this is a 2000, this is a 1000, okay, and see, front is this one established, and there is no connection. See, yes, rear is pointing here. So after having two elements, this is the position, and we are inserting the third element 30. So this is the third element. What we have to do? We have to establish the link between second node and the third node. So initially this is none, right? This is none. Now what we have to do? We are executing this small two lines of code to insert any element if Q is not empty. So rear dot next equal to new. So what's the rear? This one. Rear dot next. What is this one? This one. And this is the new, right? So this is a new 30. So rear dot next, so is equal to new. So automatically the 3000 will be set here. A link will be established here, and rear is equal to new. So the rear will be pointing in this position, right? So hope you understood this one. So a very simple code. So with the two steps. So here we need to check two conditions. One is if Q is empty. If Q is empty, so create a node and initialize both the front and rear to that particular node. And if Q is not empty, simply change the rear dot next to new and rear is equal to new. That's it. Right? So hope you understood this one. Next we will go with the deletion operation. Deletion. So we will take 3 elements and we will see the deletion operation. So here the deletion operation will be performed from the front end. So let us write deletion. Let us take 3 elements. Or we will take the 4 elements. See 10, 20, 30, 40 and the address are 1000, 2000, 3000, 4000 and the address is 2000, so there will be link from 10 to 20. Here it is a 3000, so there will be link from 20 to 30 and here it is a 4000, there is a link between 32 and 40 and this is the last one, so none, and this will be pointing as rare and this will be pointing as friend. Now what we have to do? We need to apply the delete operation. So here the deletion will be done from the front end, right? So case 1. So case 1 means if stack is empty, sorry, queue. We are talking about the queue. So if queue is empty. So previously we have checked the condition if queue is empty. When we say the queue is empty, so simply if rare is none or front is none, simply we can say queue is empty. So we can display the queue is empty. Deletion operation can't be performed. So because we can't delete the element from the queue which doesn't have any elements, right? Empty queue. From the empty queue we can't delete the elements. So we can simply display that empty queue. And case 2. So queue with single element, single node, queue with single node. For example, consider this one. So 10 and none. So this will be the friend, rare. So if the queue is having the single element, then simply we can initialize that to none. So how can we check? Simply we can check if friend is equal to rare. So if both are equal, that implies that is only a single element. If the queue is having only the single element, that is nothing but friend and rare are initializing to the same element, right? So if friend is equal to rare, simply you can give a friend is equal to none. So none will be initialized to friend, so automatically this node will be deleted. This node will be deleted. So that is a condition to check to delete the element if queue with single node. Now the third case, queue with multiple nodes. So I am erasing this one. Hope you understood this case 1 and case 2. Empty queue, queue with a single node. Then case 3. Case 3, queue with multiple nodes. So let us take this example, 4 nodes. 4 nodes are there, right? So what we have to do, we need to change the friend because the deletion will be done from the front end itself. Okay, so first initialize this friend to temp. Initialize this friend to temp. You need to change the friend value. So obviously after executing this one, so temp will also points towards the first element. Temp is also points towards the first element. Now simply you can change this temp to next element. Okay, temp to next element, or you can change the friend. So friend is equal to friend dot next. Friend is equal to friend dot next. So what is a friend dot next? Friend dot next is 2000. So friend will be moved to 2000. So immediately after executing this one, so the friend will be here. Now what we have to do? The temp should be none. So simply you can write the temp dot next is equal to none. So obviously there will be none here. So this element will be deleted. Or simply you can write temp is equal to none. temp is equal to none. So this node will be deleted. So if you disconnect, that means here we need to remove the address of the next node. So immediately there will be, the connection will be lost between this element and this element. So for that purpose we are taking temp.next equal to none. So temp points to the first node. So temp.next is equal to none means there will be, the address will be removed so that the link will be disconnected. So we have already moved the friend. So after deleting the first node, the friend will be moving towards the second node. So that happens in this case. That happens in this case. Right? So by using this simple code, so we can perform the deletion operation. We can delete the element from the front end. So once again, if you delete this one, now front is here. So once again, if you want to delete, apply the DQ operation. See, temp is equal to front means again the temp value points here. So front is equal to front dot next. Front will be moved to 3000, right? Front will be moved to 3000. So here the front will be there, and here it will be removed. And temp dot next equal to none. Temp dot next is equal to none. So the address will be removed. So automatically the link will be disconnected. Temp is equal to none, and this will be deleted. Now front is here. Once again, if you want to apply the delete operation, the front will becomes here. And if you want to remove the element, it will check for front is equal to rare, the case 2. So front is equal to rare, this is single node, so automatically the front is equal to none. So this node will get deleted. Right? So this is a simple code for deletion operation. So we have written 3 cases. One is a queue is empty, queue with a single node, and queue with multiple nodes. Right? A simple code. So unless you draw the diagram, it would be difficult to imagine this one. So if you draw the diagram with the multiple nodes, then it will be very easy for you to write the code. Only the 3 steps. Only the 3 steps. Right? Now, the last operation, that is a display function. So how can we display the elements? How can we display the elements? Display, right? So simple. Here the we'll take so let us take the case 1. Case 1, queue is empty. So previously we have seen if queue is empty means nothing but friend is none. Simply we can say queue is empty, so we can display the queue is empty. And case 2, so we need to travel from first node to the last node. So we can simply iterate the statements until the friend, or simply, for example, if you consider 2 nodes or 3 nodes in the queue, so 30, and this is a none, and this is a 3000. So the address of this one is 3000 and 20, and here it is a 2000, and here it is 1000. So this will be the friend, and this will be the rare, right? So we should not change the friend, right? We should not change the friend, but we need to print all the nodes from friend to rare. So in order to travel this control from first node to the last node, so first step we need to do is just initialize the friend to temp, so that we can move the temp value. So obviously the temp will be pointing here. So while temp, that means until the temp is available. So we are just moving. Okay. So just print data. So I will write the syntax. While execution. Don't worry. So we need to print each and every element, and we have to move the temp value. Temp is equal to temp dot next. So once a 10 is printed, then temp will be moved to 20, and temp, that means a true, it's not none, right? It is pointing towards some other one. So temp dot next, okay, print data, 20 is printed, temp dot next, again temp is here. So while temp, yes, temp is equal to temp dot next. Now temp is none, 30 is printed and temp is none. Then while temp, none, so it will be stop. Hope you understood, right? So temp, see for example, while temp, so temp is nothing but 1000. see, temp is nothing but 1000, right? So immediately print data. So 10 will be printed and temp is equal to temp.next. So temp is equal to temp.next, that is 2000. So obviously this temp will be pointing here. Now again, while temp, so temp is nothing but 2000, it's not none, so it is true, right? So what it display? It displays the 10, so 20, the data, it will display the data 20, and temp is equal to temp.next. So here the temp is equal to temp.next means 3000. So obviously the temp will be pointing here. Temp is pointing here. Now again, while temp is equal to 3000, it's not none, so obviously print data. So 30 will be printed here, and again temp is equal to temp.next. Now the temp becomes, see, none. So while temp, so here the condition fails, then it stops. So the value of q is 10, 20 and 30. So we are checking only two conditions in this display function. One is if q is empty and if q is not empty. So whenever the front or rear is none, that implies the queue is empty. And if it is not none, simply we have to write the code. So we need to travel from first node to the last node, and we need to display all the elements of the queue. So for this we will write the menu. So we will write some iterative statement and conditional statements, so repeatedly, and we can perform the NQ operations and the DQ operations. So I'll execute the code in the interpreter. So let's move on to the interpreter. Hello friends. So just now we have seen the theoretical part of implementation of Q. Now I'll write the code and I'll execute and I'll show you. So first let us create a class for the node, so which will be having a two variables. So I'll have to initialize them. So this is a constructor we need to use, and X is the element to create the node. So self.data will be the X, and self.next will be none. And also we need to create one more class for the queue, so where we have to write all the operations. Initially write down the constructor and initialize the parameters. So self.friend is equal to none, and self.rear is equal to none. And here we need to write down the functions. So one is a NQ, which is an insertion function. So NQ operation. So the first parameter will be the self, and here we need to check whether the queue is empty or not. If it is empty, we have to insert. So first let us take the input. So X is equal to int of input. So enter element to be inserted into queue. So now next create a new node. So new is an object for node. So X will be copied to the data and next will be none. Now if the self.friend is none, that implies it's an empty queue. So if it is empty queue, we need to initialize the front and rear to the same thing. So front is equal to new, and self.rear is equal to new. And then if it is having one or more element, simply you can write it self.rear.next is equal to new and change the rear. So self.rear is equal to new, assign new to rear. So we need to change the rear value. So the insertion will be done at the rear end. That's it, right? And the next, this is the NQ operation, just we have seen. Next, a DQ, that means a deletion. So deletion operation will be done at the front end, and here we need to check for the three cases. One is if queue is empty. So whenever the queue, when the queue is empty, if self.friend is none, that implies the queue is empty. Simply you can write here. So print, so queue is empty. And the next case is first node, it is having only first node, right? Only one node. So self.friend.next is none, or simply you can compare if front and rear are equal. If front and rear are equal, right? That also you can use. So then simply what we have to do, so we need to pop the element from the front end. So pop element is, so what is the popped element? Self dot friend dot data, right? Then what we have to do? We need to change the friend, right? So self dot friend is equal to none. So we need to delete that. Else, that means if the queue is having a more number of elements, then simply change the change the friend value and make the first node as none. So temp is equal to self dot friend, and simply you can write this one the same thing. So because the popped element will be always the friend dot data, and change the thing self dot friend is equal to temp dot next. So temp dot next value is will be initialized to friend, and then go with the temp is equal to none. That's it. And the third function, display function, so which will display, and here also we need to check two conditions. One is if self dot friend is none, simply queue is empty. So the same thing we need to write here. And else, that means if it is having a more number of elements, so simply you can display one by one. So print elements of queue are, so what are the elements? So while temp, you need to travel. So first we need to initialize the self dot friend to temp, so that we can travel from first node to the last node using the temp value. So while temp, so until the temp is none, this loop will be repeated. So print temp dot data end is equal to, and move the temp to next, temp of next, and write down the front and rear, display the front and rear. So friend of queue is self dot friend dot data, print rear of queue is self dot rear dot data, right? That's it. So we are displaying only the front and rear, and now we need to create an object for queue, so that we need to, I mean, if you want to call these functions enqueue, dequeue, and display, so we need to create an object for the queue class. So I am creating the queue class, and here I am writing the menu, I am writing the loop, right? So print enter option from below, and here I am writing the options. Print 1 for enqueue operation, in the next line 2 for dequeue operation, and in the next line 3 for display, and the next line 4 for exit. And we need to read the input. So option is equal to int of input, so it will prompt for the input, and now we need to check these options. So if the option is equal to 1, simply we can write here enqueue operation. We have to perform the enqueue operation, right? So call the function. So print, call the function. So queue dot enqueue, and elif, if the option is equal to 2, print dequeue operation, and call the function dequeue function. So queue dot dequeue, because the queue is a object for queue class, right? And next elif option is equal to 3, so that's it. display function. So print the, call the display function here. So q dot display, and else if any other value, simply you can go with the break, right? Break. Now see, execute. So I'll go with the NQ operation. So 10, and again NQ operation 20, again NQ operation 30. So let's go with the 3, that means a display operation. So 10, 20, 30. So front of the Q is 10. So here we have given end attribute. So here you will give /n, and we'll stop this one. So go with the 4, and again re-execute the code. So 1. So let us take the input 10. So again NQ 20, again NQ 30. So go with the display operation. So the display operation 10, 20, 30, front is 10 and rear is 30. So go with the 2 DQ operation. So the popped element is 10 because the front is 10. So 10 is removed. Go with the display function. Now the elements are 20 and 30. Front of the Q is 20 and rear of the Q is 30. Again go with the second DQ operation. So popped element is 20. Go with the display operation. So the element is only 30. So front and rear both are pointing towards the same 30. So go with the DQ operation. Popped element is 30. Again go with the display. So you can see the Q is empty because there are no elements. So Q is empty. And if you were again want to delete the element from the empty Q, still we are getting the same result. That is, a Q is empty. So hope you understood this code, simple code. So unless you draw the diagram, it would be difficult to write the code. So particularly in the data structures, just draw the diagram with the nodes. So immediately you can write down the code for all the functions. So hope you understood this NQ, DQ and display operations of Q. So this is the implementation of Q using linked list. So let's stop here, and if you are having any doubts regarding any of these operations, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.